Hello student, the question says plot the corresponding reference circle for each of the following simple harmonic motion. Indicate the initial t equals to 0 position of the particle, the radius of the circle, and the angular speed of the rotating particle. For simplicity, the sense of rotation may be fixed to be anti-clockwise in every case. So as given four cases, we have to represent where they lie in the circular path. So what is the reference circle we have taken to represent the corresponding circular path? So in the last problem we have seen what is a standard equation. Suppose if you have a particle and it is rotating in a circular path. This is x-axis, this is y-axis. Suppose if it is rotating in a circular path continuously. So let me just extend this entire x-axis. So this is my y-axis. So if the particle is traveling in anti-clockwise direction. So since it is traveling in anti-clockwise direction, let us assume this is the position of the particle. If this is the position of the particle, if I take this angle as omega t, and let us assume this is the initial phase difference, some initial phase difference of phi initial. So there is some initial phase. From here, the particle traveled anti-clockwise. So our particle has traveled anti-clockwise and reached here. So it has reached here. I'll draw blue color for its new position. Now, imagine it is traveling with a speed of omega t. It is traveling with an angular speed of omega. So after t time, the angle it will cover would be omega t. Since it is a circular motion, this value would be equal to the radius of the circle. Now, if I draw its projection on the x-axis, if I try to draw what is its projection on the x-axis, so the displacement in x direction would be simply displacement of the projection in x direction. How do you find the displacement? We can construct a triangle here. If we quickly construct a triangle, this one would be r. The total angle with the x would be omega t plus phi initial. So this value, the equation that represents the x direction for a body rotating in circular motion would be simply r cos omega t plus phi initial. Similarly, the equation that is representing y is y equals to r sine omega t plus phi initial. This is one thing you have to know. Right now, the method that we are going to learn is a very blunt way to solve a problem. In that blunt method, the value of x is always consider r cos omega t plus phi initial, and the value of y is always considered as r sine omega t plus phi initial. Now in this, what are the important things that you have to remember? That we are assuming anti-clockwise rotation as positive. That means omega we will substitute as positive if it is anti-clockwise. We will substitute omega as negative if clockwise is given in question. This is one thing that you have to remember. The next one is this initial phase is measured with respect to positive x-axis, measured with respect to positive x-axis. That means that if this is my x, if this is my coordinate axis that we have taken x and y, so you should always start the angle from here and you should keep on traveling in anti-clockwise till you reach the desired position of the particle. So you should always measure the angle from the positive x-axis in anti-clockwise direction only. So this is first thing that you should know. Once you know this, we have x equals to r cos omega t plus phi, y equals to r sin omega t plus phi, x equals to r cos omega t plus phi initial. Let us say you decided, no, convert this into sine. We can convert a cosine into sine by simply adding pi by 2. So we can write sine into omega t plus phi initial plus pi by 2. So remember, you can convert a cosine function into a sine function by adding pi by 2. Similarly, suppose you have y equals to r sine omega t plus phi initial. You can convert a sine function into cosine function by removing a pi by 2. So you can take this omega t plus phi initial and you can remove a pi by 2. Whatever is there, so if you remove a pi by 2, it will become a sine function would become a cosine function. So remember this. This is how you convert. If you want to convert a cos into sine, you have to add pi by 2. So if you take a cos, add pi by 2, it would become a sine function. You take a sine, remove pi by 2, it would become a cos function. We can, how did we get this? Means with graphs, we can easily say this. Right now, I won't do it, but I'll just give an introduction to this. So if you look at a cosine cos graph, this is how a cos graph would look like. So if you add pi by 2 to a cos graph, the graph would shift a little bit to the, if you add pi by 2, the graph would shift a little bit. When the graph shifts a little bit, so a cos function could become a sine function when it is, especially if we are dealing with anti-clockwise directions. Anyway, right now, this explanation would take some time. I thought to start it, but it will take some time. Let us directly get into the problem solving now. Now, the first function is given as x equals to minus 2 sine 3t plus pi by 3. He has given x equals to minus 2 sine 3t plus pi by 3. I always compare with x equals to a cos omega t plus phi initial. But we have this negative sign. If you want to eat a negative sign in front of a trigonometry function, you have to add pi, especially in front of a sine function. So 2 sine 3t plus pi by 3. So add 1 pi to this. Okay, I have added 1 pi, I have eaten this. But it is still a sine function. I want cosine function. I told you we can write cosine function as sine function by adding pi by 2. So sine omega t plus phi initial plus pi by 2. Now you compare these two. If you compare these two, it is very easy now. So from this, we can clearly see A is 2, omega is 3, and we got phi initial plus pi by 2 equals to pi plus pi by 3. So you simply get phi initial equals to pi plus pi by 3 minus pi by 2. So you will get pi plus pi by 3 minus pi by 2 is pi plus pi minus pi by 2. It would be pi by 2 plus pi by 3. So how do we represent that on a graph? If you want to represent the position of that circle, so let us take a circular motion. So this would be my x-axis, this would be my y-axis. So what is the radius of the circle? Amplitude is given as 2. So you can directly write the amplitude of the circle is 2. So this entire circle, the amplitude is 2. So this is 2 centimeter or meter, it is not mentioned. So he has given x is in centimeter, so it would be 2 centimeter. Okay, the radius we got 2 centimeter. Omega anti-clockwise we got 3 radian per second. So we got the value of omega also. Once we got omega and this one, now we have to plot its position. If you see, its initial phase is pi by 2 plus pi by 3. As I told you, we'll always start from the positive x-axis. First, I will move pi by 2. If the radians is confusing for you, convert it into degrees. 90 degree plus 60 degree. So from this axis, this is the axis. You have to travel first 90 degree in anti-clockwise direction. Okay, I travel 90 degree in anti-clockwise direction. Then further 60 degree. So further 60 degree. So total it would be 150 degree. After traveling 150 degree, we have to mark its position. So if I try to mark its position would look somewhat in this way. Now, where is the position of the particle? This is the position of the particle at t equal to 0. So this is the position of particle. This represents the position of particle. So I'll draw it with a, I will show it in the next page with a very like expanded image. So this is the position of the particle. So when somebody says the equation is x equals to minus 2 sine 3t plus pi by 3. So this is where the particle is, and this is how the particle, so from here onwards, the particle would continuously travel in anti-clockwise direction continuously. This is what happens. Now let us look at the next one. We will follow the blunt method only. After that, I'll teach another alternate method also. So x equals to cos pi by 6 minus t. We don't want this negative sign. The speciality is that cos minus theta is also equal to cos theta. So we can just flip that. So I can write cos t minus pi by 6. Now compare this with our regular equation x equals to a cos omega t plus phi initial. So based on this, we can get a equals to 1, omega equals to 1. We got phi initial is minus pi by 6. As I already told you, phi is always measured in anti-clockwise direction. But if we got phi is equals to pi by 6, indirectly they are telling us to go, go measuring it in clockwise direction. So again, let us take a circle. How do we represent it? Simply this is x-axis and this is y-axis. Now this value we got it as 1 centimeter. Now I have to go minus pi by 6. If anti-clockwise is positive, so minus pi by 6 means indirectly is telling us to go clockwise direction by how much? Pi by 6. Particle is still going in anti-clockwise direction only. But the measurement we are taking it as in the clockwise direction. So the location of the particle is here. This will be the location of the particle. So this would be equal to minus pi by 6. If you are like, sir, no, sir, this is confusing for me, you take always measurement from the anti-clockwise direction only. So the speciality of trigonometry function is that if you add 2 pi, nothing would change. So if I add 2 pi to this, so 2 pi minus pi by 6, that means minus 30 degree plus 360 degree. So you will get 330 degree. So 330 degree means since you want positive number only, from here you travel 90, another 90, and you travel another 90, 270, then another 330 degree means 270 plus 60 degree. So if this will become 60 degree, so this entire thing would become 270 degree. So that one also is bringing me at the same location only. Rather than doing so many steps, it is better to simply write 5i is minus pi by 6, right? Rather than going in this way in anti-clockwise direction 330 degree, just to go in this way, you will get the location of the particle. So this is the at t equal to 0, this is the location of the particle and it is going in this way and the radius is 1 centimeter. Angular frequency is 1. I think it is radian per second only. So this is how we got this. Now we'll go for the next one. C, which is given as x equal to 3 sine 2 pi t plus pi by 4. The standard one is x equal to a cos omega t plus phi initial. Since there is sine 1, so a sine omega t plus phi initial plus pi by 2. So if I compare these two, so a is 3 centimeter, so omega is 2 pi, phi initial plus pi by 2 is pi by 4. So phi initial is minus pi by 4. So as discussed earlier, we can quickly draw this. So take a circle and this one would be in this way. This one would be in this way. So the radius of the circle, we got it as 3 centimeter. So the radius of the circle is 3 centimeter. And we got initial phase differences minus pi by 4. So I have to, this is the reference axis. Remember, this axis is always, this side is always the reference side. From this you go minus pi by 4. That means in this way. Because anti-clockwise is positive, clockwise is taken as a negative. So you go minus pi by 4 and you will get the original position of the particle. So the original position of the particle is somewhere here. Remember, the particle is still traveling in anti-clockwise direction only. Since it is minus pi by 4, you went in this way. So this would be minus pi by 4. If you don't like minus negative values, you can, if in clockwise terms, you can tell, you can add 2 pi minus pi by 4 plus 2 pi. So it would become 8. So 7 pi by 4. So you can get this entire angle. From here, if you measure this angle again, this entire angle is 7 pi by 4. It will be 315 degree. Now let us go for the next one. So we got a t equal to 0. This is the position of the particle. Let us solve the last question. X equals to 2 cos phi t. This is cos, no issue. Compare with the standard equation x equals to a cos omega t plus phi initial. If we compare it, you are getting a equals to 2 centimeter, omega equals to pi radian per second, and initial phase we are getting it as 0. That means the particle is at the exactly at the starting position only. So we can draw this in this way, and the particle is initial phase is 0. So the particle is here on. This is the location of the particle, and this length is given as 2 centimeters. So at t equal to 0, this is the location of the particle. So here at t equals to 0, this is the location of the particle at t equals to 0. Next, at t equals to 0, this is the location of the particle. And the last one at t equals to 0, the original one, this is the location of the particle. Is this the only way to solve the problem? Is there no other way to solve the problem? We can solve the problem in a different way also without using this blunt formula. Okay, let us look at that method to solve this problem. So the method to solve the problem is here given a equals to x equals to minus 2 sine 3t plus pi by 3. What you will do is substitute t equal to 0. You will get x equal to minus 2 sine pi by 3. Okay, if it is minus 2 sine pi by 3, so if you draw it on a circle where it will be on the negative side. So you will get this as minus root 3. Minus root 3 means it should be on the negative side. Since the total value is minus, amplitude is 2, so we got amplitude is 2. Since it is minus root 3, so it will be somewhere here, because this is taken as 0, 0. So this is my x, this is my y. So it should be minus root 3 means somewhere here. So where will the particle be located here? In which two instances the projection would be here? The answer could be either this arrow could be representing that, or either I will take another color, either this arrow could be representing that. Either this arrow could be representing x equal to, both arrows have same x projection as minus root 3. Now whether this blue arrow is correct, whether the particle is located here or whether the particle is located here, which is the correct location at t equals to 0. To understand that, you should understand what happens as time increases. We can see as t increases, okay, the sine phi value is the phi value is increasing, because as the t value increases, this entire thing is called as phase. So phase is increasing. If phase is increasing, we know sine increases with theta, because still it did not reach 90 degree. Since it still did not reach 90 degree, so sine value increases. If sine value increases, so the overall value of negative displacement increases. So that means with the time, it should become minus root 3, and eventually from minus root 3 to it has to become minus 2 with time. So let us say if the particle is here, if the particle is here, if this is the location of that, so with the time, as the arrow is going in this way, its x projection would be slowly going towards the mean position. If it is if the arrow is going in this way, its x projection would be going towards the mean position. Since it will be going towards the mean position, we get with the time the x value is actually becoming 0. It is not becoming minus 2. So this arrow is wrong. Then what is the right arrow? We can see here clearly that with the time, as it is going in this way in anti-clockwise direction, its x projection value keeps on increasing. Since that means this arrow is going towards 2, its x projection is going towards 2. So out of these two, the correct answer would be this one is the correct answer. So this arrow is wrong. So the green color arrow would be wrong. So this would be wrong. And the correct answer would be this one. Then what is the angle is? So angle is pi by 3. Angle with the, this is given as 2 sine pi by 3. So this would be pi by, this would be pi by 3. Since it is given sine pi by 3. So I hope this is clear to you. Here we are not using any standard formula, but if you can do it with standard formula, all these confusions won't be there. That's a very blunt way to do it. Next, B is x equals to cos pi by 6 minus t. Substitute t equal to 0, you get x equal to cos pi by 6. Cos pi by 6 means it is root 3 by 2. The amplitude is 1. So when I draw a circle, this is one thing, this is another thing. So its amplitude is root 3 by 2. The amplitude would be root 3 by 2 at two different instances. Here also amplitude is root 3 by 2. Here also its x projection is root 3 by 2 only. In both the cases, the x projection is root 3 by 2. But what happens as time increases? You can see as time increases, the phase value, that whatever is inside, that is decreasing. Since it is decreasing, cos value increases, so cos phi value increases. That means the x value must increase. Since the x value increases, that is x projection increases, if I take this situation, if I assume this blue arrow is correct, as it is going towards this position, its x value is slowly decreasing, it is shrinking. So this can't be the answer. So the correct answer would be this one, because as it is traveling in anti-clockwise direction, its x projection value is going towards 1, because the maximum possible value is 1. So eventually root 3 has to become 1. So in this is the, so the bottom one is, this is the right arrow. So this will be the original location. This is the location at t equal to 0. So this is wrong. So this is one more method to solve the problem. Now let us look at the remaining two also in the same way. In the C part, x equals to 3 sine 2 pi t plus pi by 4. So t equals to 0, x equals to 3 sine pi by 4. So if I try to draw this quickly, so 3 sine pi by 4. So we have this place and this place. That means it is sine pi by 4 means it would be 3 by root 2 since the amplitude is 3. So this place and this place is there. As you can see, as time increases, the sine value is also increasing. That means x has to increase. So in anti-clockwise direction, x increasing means here, as in this case, in this arrow, if I take, as we are going in this way, its projection is decreasing. So this can't be the answer. The correct one would be this one, because as we are going in this way, its projection is also going towards the right extreme. So this is the correct position. So at t equal to 0, this is the position. The position. And the last one, x equal to 2 cos pi t. So if here also, if we do that, there is no confusion here, because at t equal to 0, x must be 0. So the only place is this one. So directly we can draw an arrow here and the particle would be going. This is at t equal to 0. This is the easiest one out of all this. Now remember, this both the methods are equally easy. Once you understand it, both the methods, if you are good with like trigonometry slightly, like pi by 2 and 7 pi by 4 and all those things, my suggestion is learn this blunt method only. With this blunt method, you don't have much thinking to do. Directly you can solve the problem. But both the methods are equally easy. Once you keep on solving the problems in both the methods, whatever you feel convenient, you use that. Hope you understood how I have solved. Thank you.